Hi, everybody. My name's Andrew, and this is,
I'm Destiny Clowers.
And I'm Jared Homishak.
and we're going to be going over some questions about Chapter 10. So, here we go. Jared, can you explain what is meant by the doubling system on question one?
Sure. All right. So basically, in this first question, you have various systems. Like you have a mouthful is you have one jack is equivalent, two jacks is equivalent, or half a jack is equivalent to a Jill. So in that case, come on, two jacks would be equivalent to one Jill, and ultimately, every unit of measurement is either going to be half of the unit or twice as much as a smaller unit, depending on which direction you're wanting to go. And with the pail, what happens is you're getting half, because 1 gallon is half of the pail. It helps you fill up half the pail. So you keep filling up half of what is left of the empty pail each and every time. And eventually, you're going to get to the point where you're one half of an item short, which in that case was a mouthful. So basically, the doubling system means that each unit is double the size of its smaller unit. Each of the is twice the size of its smaller unit. Good question. Thank you.
Yeah,
Destiny, can you explain what the metric system is?
Of course, thank you for asking.
You're welcome.
So, the metric system is a measurement system that's used all over the world, and these systems are kind of in powers of 10. So, this will kind of give you an idea of what that looks like. You can see how down here it starts with milli, and for example, a milli equals 1 over 1,000, or you can say 1,000. And then a centi is equal to 1 over 100, or a hundredth. And then deci is 1 over 10, or a tenth. And then it continues to go all the way up, like a deca equals 10, hecto equals 100, and kilo equals 1,000. And as you can see, each measurement goes up by the power of 10, and so on. It keeps going on. But that's kind of what the metric system is, and everyone worldwide uses this system. So thank you for asking.
You're welcome.
Okay, Andrew. So the fundamental unit of length in the SI unit is meter. How many meters are in the given length?
well, just like you had previously said, you had explained the kilometers, the hectometers. Pretty much, in 1 kilometer, there is 1,000 meters, and 1 hectometer is 100 meters. One decameter is 10 meters, and a decimeter isn't even 1 meter, it's 0.1 meter. So that's how many meters are in a given length.
Good job.
And I have a question for you, Jared.
Go for
It'll turn over.
it.
What's the
There you
difference
go.
between area and perimeter? What's the difference between the two?
All right. Well, I am glad you asked. First of all, there we go. Should be going. Area represents the amount of space that is inside of a figure. So, for example, in our little rectangle here, it's three by 5 units. So, to get that area, you just multiply 3 by 5 to get 15 square units. And as you can see here, there are 15 blocks inside of that rectangle. Now, perimeter, on the other, there we go, there it is. As you can see, there are 15 square units inside the rectangle. And that's how 3 times 5 represents the area of 15. Now, perimeter just simply accounts for the 4 sides of your figure. So you're just not counting what's in, but you're counting what's outside of the figure. So in this case, you just add up the lengths of each individual side, such as here with our big rhombus over here. You just add up lengths A, B, C, and D to find the perimeter. Good question. Now, I forgot. I'm going to compare here to one of the triangles you worked on. If it had a base of 82.3 meters and a height of 41 meters, then you multiply just half of the base times the height to get the area that is inside the triangle and add up all the sides to find. Oh, hold on, went too far. All right. Destiny, what is perimeter, and can you find the perimeter of this figure?
Of
Sorry for
course.
jumping ahead.
That's okay. So perimeter is the border or the outer boundary of whatever figure you're looking at, and it's usually a two-dimensional figure. So this means in this figure that we're going to add up the side lengths and we're going to add them together, and that's going to give us our perimeter. So 48.0 meters plus 69.0 meters plus 82.3 meters. That equals 199.3 meters. Now notice we didn't add the 41.0 meters right here because perimeter only involves the outside, which are these right here. And since 41.0 is in the middle of the figure and the inside of it, we're not going to ever add those into our perimeter. So that's why we didn't add that. But that's how you find the perimeter for each figure.
Well, thank you.
Of course. Now, Andrew, what is area? Can you also find the area of this figure?
Yes. All right. So area is the amount of space inside the boundary of a plane figure. In the last question, we saw that perimeter was dealing with the outside of the shape, right? Well, area deals with the inside of the shape. Now, depending on the shape, there are different formulas to find the area. And since our shape is a triangle here, the formula we're going to use is A equals 1/2 times B times height, H. Then we're just going to identify our base and our height, and we'll plug those numbers into the formula to solve for the area. So when we do that, this is what it looks like. So we have 1/2 times 82.3 times 41, and we get 1,687.15 meters squared. And so that's how you solve for the formula right there. You just plug in. And Jared, what does pi represent?
Well, first of all, it doesn't represent the piece of Oreo pie there, as tempting as that looks right about now. But what pi represents is the concept. It actually represents a number. So you can see over here it is formula-wise, it is represented by circumference over the diameter can be calculated to get pi, which goes to let's see, 3.14159.265. That's about as far as I can count in terms of digits of pi, but it's endless. I could not tell you how far it went. And basically, so in terms of our circle here, here's how let me demonstrate it for you. For the area of the circle, the formula for that is, all right, it won't let me draw on this one. So, but basically the area of a circle is pi times your radius squared. So in the problem you worked on with the circumscribed circle, you basically were working with areas of circle, and since they were in units of pi, there was no need to calculate pi because you were working with units of pi. So subtracting 50 pi minus 25 pi, you don't have to calculate what pi represents because that's staying constant. But I'm glad y'all asked about it, and
yeah.
Thank you so much. Now, Destiny, how do you find the area of the smaller circle?
That's a great question, Jared. In order to find the area of this smaller circle, we've got to use the formula, the area formula of a circle. And the area of a circle formula is pi r squared. Now, in order to use this formula, we have to figure out what r is, which equals the radius. And if y'all remember, this right here, the 10 units, you can see that the circle is actually inscribed into this square. So that means that the 10 units the length of the side of the square is actually the diameter of the circle. So we can just take half of 10 and get 5 because the radius is always half of the diameter. So that means that 5 will be our radius. And then we're going to just plug in, 5 to the formula. So when we do that, we get pi times 5 squared, and that equals 25 pi units squared. So that is the area of the smaller circle.
All right.
Okay, Andrew, so using the same diagram, how do you find the area of the larger circle?
Okay, yeah, good question. I'm really glad you asked. So on the previous slide, we learned that the area of a circle formula is pi r squared. Well, that same formula applies to the larger circle too. So all we have to do is just find the radius of the larger circle so that we can plug into the formula. So in order to find the radius, we're going to use the Pythagorean theorem, a squared plus b squared equals c squared. Since we know the radius for the smaller circle, we're going to plug 5 in for both a and b. So here we go. We have r equals 5 units. The area of circle formula right there is posted as pi r squared. And we're just going to plug in right there. So 5 squared plus 5 squared, you see right here, equals r squared. 5 squared plus 5 squared is 50 because 5 squared right here is 25. 25 and is 50. And so we come out with the answer of 50 pi units squared. And so the area of the larger circle is 50 pi units squared. So glad to answer that question, y'all.
Thank you.
Yeah.
All right.
So Jared, I got a question for you.
Go for it.
All right. How do the volumes of the various figures in question 4 follow a 1 to 2 to 3 ratio?
Well, I am glad you asked that. First of all, let's try and get these figures up. Let's see if I can get these figures up here.
Okay.
All right. First of all, let's refresh. We had a cone, a cylinder, a spear, and a cylinder. I'm sorry for that mix-up. And let's see if I can't get. Aha! Here we go. All right. So once again, we have a cone, spear, and cylinder. Now remember, we calculated the formulas for the three figures to be 1/3 pi radius squared, 2/3 pi radius squared, and pi radius squared. So as a result, look at the formulas. 1/3 for the cone, 2/3 for the spear, and pi 3/3, or just pi, 1 pi, for your cylinder. Because those ratios go up by 1/3, it follows a 1-to-3 ratio, and we were able to prove that by doubling the height to get 2/3 pi r for the cone, 4/3 for the spear, and 2 pi for the cylinder. So no matter how you adjust the formulas, as long as you adjust them consistently, they will follow the 1-to-2-to-3 ratio in this scenario. Thank you for the question.
Yeah.
Destiny? Oh, sorry. What is the ratio of the cone?
That's a great question. Let me pull up the cone real fast. So this is a figure we were given, in our homework last week, and you can see the cone right here. Now, to find the ratio of the cone, we first have to have the volume of the cone. Now, these are the formulas in order to find the volume of the cone. And the first one, this is the general volume of the cone formula. So that's going to be volume equals 1/3 times base times height. Now, in order to find the base, we have to use this formula, which is going to be base equals pi r squared. And in our homework problem, we were given that the height equals 2r. So then you're going to just plug in your height and your base into this formula right here. And when you do that, you get volume equals 2/3 times pi r cubed. Now, the ratio of the cone, you're going to take the volume that you just got and you're going to divide this by the exact same thing. So when we do that, we divide 2 over 3 times pi r cubed divided by 2 over 3 times pi r cubed, and that equals 1. Anything divided by itself will always be 1. So the ratio of the cone is 1. Thank you for asking, Jared.
You're welcome.
Okay, Andrew, so what is the ratio of the sphere?
Okay, good question. So let me pull up the sphere real quick. All right, so you see the sphere
Yep.
right there? Okay, so volume of the sphere is 4/3 pi times radius squared. And this is what it looks like right here. This is the volume of a sphere. Now, in order to represent the ratio of the sphere, we have to use what we gathered from the previous question. So this means that we must divide the volume of the sphere by the volume of the cone. Now, the volume of the cone was V equals 2/3 pi r cubed. And here it is right here. So we're just going to divide 4/3 pi r squared by 2/3 pi r cubed. And when we do this, we get the answer of 2. That means the ratio of the sphere is 2. So here's the next question I had for you, Jared. Why
Okay.
did you solve other formulas before you solve for the surface area of the figures on question 5?
Very good question. And I could see where people get this mixed up, but you gotta remember one thing. The volume for the surface area is 2 times your area plus the perimeter times the height. Now as I pull up these figures, let's start by thinking about our perimeter. So for our figure here on the left, the perimeter, we just once again add up the sides. 26 plus 12 is 38, plus 17 is 55, plus 15 is 70. That's your perimeter. And then your area is half times your bases. 26 plus 17 is 43, times the height of the figure, which is 12 centimeters. For this figure, once again, you add up the perimeters. 8 plus 7 is 15, or 15 centimeters, 17. Add up your sides and then calculate the area. And that's kind of the key, because that surface area formula requires you to know the area and the perimeter before you can get all the numbers you need. Once you get those, you just got to find the height of the figure, and you will be able to solve this for the surface area with these kinds of problems and figures. Very excellent question. Thank you for asking.
Yeah.
All right, Destiny. Oh, sorry about that.
That's okay.
What is a right trapezoidal prism?
That's another good question, Jared. See if we can pull that up. Here it is. So a right trapezoidal prism is always going to have 6 faces, just like any other trapezoidal prism. So the bases, which is this top piece right here, and the piece on the bottom that we can't see equal 2 faces. And then the 4 lateral sides, which here's 1, 2, there's 1 right there, and then 1 coming down this side. Those are the other 4 faces. Now, this is called a right trapezoidal prism because the bases and the rectangular face where they meet over here, it forms a right angle, a 90-degree angle. So that's why we call it a right trapezoidal prism. And if you notice, this right trapezoidal prism, it actually creates 2 other shapes. So when I added this line right here, you could see that we have a rectangle. And of course, we've got 2 90-degree angles right here and 2 more right here. So we've got a lot of right angles in the rectangle. And this is also a right triangle. So this is how you know that this is a right trapezoidal prism. That was a great question.
Well, thank you.
Okay, Andrew, how do you find the surface area for this figure?
Okay, great question. Well, the surface area formula is already given right here. Surface area equals 2 base plus perimeter times height. And base formula is base equals 1/2 times b. So we have those two. Now we need to figure out the base. Let's get this right here. Let me pull it up.
Come on, computer, you got this.
There it is.
Yay!
So we're given all these different meters. Now this is the height, and these are all the different sides that we need to add up for the perimeter, and we'll talk about that soon. So to figure out the base, we need to multiply 15. Here's 15 and 17 together,
Mm-hmm.
and then divide the answer in half. So we got that. There. That's how you get the base. So the base is 52.5 meters squared.
Mm-hmm.
To get P, like I said previously, we add all the sides together. Don't even worry about the height. Let's just add 15, 8, and 17. We get that 40 meters right there. So we have B, and we already have P. And we already have H right here. So all we have to do is just plug in 105 plus 280 equals 385 meters squared for multiplying 2 times 52.5 and 40 times 7.
Good job.
Thank you. Thank you. I got a question for you. How did you create a single formula for surface area and volume for a figure containing multiple shapes?
Excellent question. Well, the best way to do it is to remember that those figures in that question are made up of two individual shapes. For the first figure, it's made up of a cylinder and a sphere. So as a result, you would add the surface area and volume for those. You'd have the two formulas together for the surface area and the volume to get the ultimate formula that you will use to solve for that specific figure, because since they're made up of multiple shapes. Once again, likewise, for the second figure, we repeat the process again with the surface area and volume of a sphere being combined with the right cylinder. And that's what it is for the other figure as well. So once again, the key here is just add those two formulas together to get your ultimate formula, and then just look for the missing pieces. Good question.
Yeah.
Destiny, I know we're running a little low on time, but got one more for you. What is surface area, and how do you find the surface area of this figure?
All right, Jared, this is kind of like the last question that you had, but surface area is the total area of the surface of a three-dimensional object. So in this figure, we have, of course, a cylinder, and these two edges make up one sphere. So we can add the surface area of the sphere and the cylinder together, and when we do that, we get 2 pi RH plus 4 pi r squared. And of course, we got to find the radius. And like we mentioned earlier, the radius is always half of the diameter. So that's where we got 4, because 8 divided by 2 equals 4. So 2 pi times 4 times 21 plus 4 pi times 4 squared equals 729 feet squared. So that's how you find the surface area of this figure. Now we've got one last question for Andrew, and I want to know what the volume of the sphere and the cylinder is.
Okay. So this is a pretty short one. All right. So the formula is 4 divided by 3 times pi radius cubed, and this is what it looks like. This is the whole process, but we're just going to look right here. The volume for this is 4 divided by 3 pi r cubed plus pi radius squared times the height. So when we get the answer for this, we have to just simply add pi radius squared times the height. So since we've been given the formula, all we need to do is just plug in for the answer. And when we do that, we'll then plug in 4 where the radius was. And there it is right there. You got 4. The 8 was the diameter. Half that is the radius. Plug in the 4 right there, you can get the answer. So That's the answer for that. That's the volume of the steering cylinder.
All right, you guys. Well, that was the end of our questions for this chapter. We hope that you guys learned something new. And if y'all have any further questions, feel free to ask either me, Andrew, or Jared. Well, we hope that you guys have a great night. Bye-bye.
Thank you
Bye.
so much.